So, here's the approach proposed by Preston et al. We look at the TSP as a translation problem with source being a set of 2D points and target would be to achieve a tour with minimal length depicted by a set of indices of the selected nodes. As the translation problem in NLP has made significant progress in recent years by using transformer architecture, we propose to use a similar architecture for TSP as well. We train using reinforcement learning with initial settings as those from Cole et al. As a baseline. The reward is the tour length, and the baseline is simply updated if the network trained improvises it on a set of TSPs. Now, talking about the encoder part, the set of points in a 2D space that we have as source would be converted using self-attention into a representation that would make it easier for the decoder to find the shortest path. The encoder utilizes multi-head attention, residual connections, and batch normalization. A dummy node Z is also inserted as a start token. The memory and time complexity of this process is order of n square. Looking at the maths involved here, we start with h at l equals 0, which is simply a concatenation of the dummy node Z picked at random, followed by the source of points. Then, at each layer of the L layers of the encoder, we update and calculate HL plus 1 to be softmax of QL multiplied by transpose of KL over the square root of D multiplied by V of L. And each of those intermediate terms can be calculated as the formula seen in the last three lines utilizing HL as an input. This process stops after a pass through all layers of the encoder and the output is H encoder. Now, moving on to the decoder, the decoding is done in an autoregressive manner, one city at a time. Suppose we have decoded the first t cities in a tour and we want to predict the next city. The decoding process would have 4 steps. Part 1 would be to start with encoding the city I sub t and positional encoding. Part 2 would be to encode the tth city and the partial to itself using self-attention. Part 3 would be to query the next city with non-visited cities using multi-head attention. And finally, part 4 would involve generating the final query using a single head attention and index sampling. So, part 1. We start with encoding of the IT city. It is calculated as h dec sub t equals h enc sub it plus positional encoding at t, where h dec sub 0 is initialized as h enc as the dummy node z. Add positional encoding p to order the nodes in the tour. The positional encoding is calculated as sine 2 pi fi times t if I is even and cos 2 pi fi times t if I is odd. The decoder would have access to the cities added in the tour so far and would therefore add the ID city at its optimal position in the partial tour. This process can be seen in this graph at the bottom right. Part 2. Encoded tth city with the cities in partial tour using self-attention. That generates the query for time t. Then multi-head attention, residual connection, and layer normalization are used in this layer. The memory and speed complexity is order of OT at each recursive step. This graph at the bottom right depicts how the new city is added to the encoder tour using all the previously visited cities. Part 3. The attention mechanism is utilized with masking the visited cities to compute masked self-attention using the query and the unvisited cities. This queries the next city with unvisited cities, and multi-head attention, residual connection, and layer normalization are used in this step. The memory and speed complexity is order of n at each recursive step. The graph at the bottom right depicts how the computed partial tour is masked and we query the next city using the unvisited nodes. So, part 4. Here, we generate the final query using attention and index sampling. A single head attention is used to get a distribution over the non-visited cities. Finally, the next node IT plus 1 is sampled from the distribution using Bernoulli during training and greedy, that would be indexed with maximum probability at inference time. And the memory and speed complexity for this step would be order of n. Now, over to Anushka.